Hello, my name is David. Today I will be going through PSAT test 290 with you, and we're going to tackle Math Module 1 and Math Module 2. All right, if you're ready, let's begin. Question number 1. A contract for a certain service requires a one-time activation cost of $35. So that sounds like an initial cost. And a monthly cost of $23. So this could be an initial cost as well. It could also be a rate, so where we multiply by the number of months. Which equation represents the situation where C is the total cost in dollars of the service contract for T months? So that kind of confirms that this is going to be a rate. So let's start setting up our model. Well, most models on the SAT follow a linear model, and that's what we're going to be using here. C is the total cost. We're going to pay $23 per month. And so if you kind of imagine it being US dollars per month, well, you would want to multiply it by T months. So that way the units cancel out and they give you dollars. Lastly, we're going to add our initial cost to it. Now, for a lot of SAT problems, they're very tricky. They have like different wording on here that can mess with you. So one thing that can always be valuable when checking your model is verify by using test points. So for example, if I took T and C and I plugged in 0 months, well, based on the context of the question, I can understand that if someone got the service and they didn't get any months of service, but they still had to pay the one-time activation cost, then their total cost would be $35. If, on the other hand, though, they had 1 month, then they would have to pay the 1 month of $23 and then add 35 to it, which would make it be 58. This right here matches what we currently have. So let's go through the answer choices. So for A, instead of multiplying it, they divided it, which is something to try to trick you and make you get mixed up on the numbers. B, they kind of switched things around and put the one-time activation cost below, so we can cross that one off. C matches what we have exactly, which is perfect. And then D looks right, but they switched numbers again. So, question 2. The function f is defined by f of x equals 3x minus 8. What's the value of f of 7? So this is called function substitution. So you plug the 7 in for everything on the inside. So wherever there's an x, we're going to replace it with a 7. So we should get 3 times 7 minus 8, which is 21 minus 8, or 13. B is the answer. Question number 3. We have 8x minus 7x plus 130 is equal to 270. What is the value of x in the solution? So it's a simple linear expression that we're going to simplify. So 8x minus 7x is going to be 1x. And then we're going to want to subtract the 130 to the other side. So subtract 130 to both sides, and then you get 1x is equal to 130. And that is our answer. Question number 4. Each of the 157 gemstones can be classified as one of 3 classifications, shown in the frequency table below. So again, a frequency table just shows you that and how many of each of them there are. So this is kind of like the value on the left, and then this is how many of them appear. If one of the gemstones is selected at random, what's the probability of selecting a gemstone of color Y? Well, there's a total of 3 Ys out of a total of 157. So that would be our probability. And we should look for that answer first before simplifying. And so right away, I see it as answer A. So we can pick it and go on to the next question. Question number 5. The shading ratio shown represents the solution to which inequality? So this is a linear inequality, and we're wanting to shade above it. I notice it has the y-intercept of 0, -6. It has an x-intercept of 9, 0. So we could use the fact that since it's in slope-intercept form, we want to focus on ones that have a -6 here at the end. And this is the only one that has it. We could also go forward and find the slope. So slope is going to be the change in the y or the change in the x. So -6 minus 0 over 0 minus 9, which gives us positive 2/3. So A has both the right slope and the right y-intercept. It is the right answer. Question 6. In the triangle ABC, AB is equal to 4 at 680 millimeters, 4,680 millimeters. BC is 4,680 millimeters. Which statement is sufficient to prove the triangle is equilateral? So I'm going to draw a generic triangle to begin with. And we have 4, 6, 8, 0, 4, 6, 8, 0. And this is going to be AB, and this is going to be BC. You could draw a different triangle for yourself too, but this is what I did for this problem. So we want to put an equilateral triangle. So we either need to show that the top angle is 6 degrees, or we need to show that the bottom side is the same as the other two sides. So looking at these choices, we want to make sure to pay attention to the units here. And because they're all in millimeters, which is what the starting problem was, we want to have it the same number of millimeters, which is why the answer is A. If this question was a little bit trickier, it would have mentioned that 1,000 millimeters is equal to 1 meter. And then they could have had it be, instead of A being the answer, it could have been D, where 4.68 meters is your answer. So to try to distract you. But that is it for this question. Question number 7. The function p of t is equal to 24.38, 1.36. So this is an exponential model with an initial value of 24.8 and a percent increase of approximately 3.6%. From 1984 to 2018, where t is the number of years after 1984. So things to think about is when is t starting off, so that we can always keep that in mind in case the question asks us about that. According to the model, which is the best interpretation of p of 8 is equal to 32.91. So in this case, we know that t is the number of years after 1984. So 8 years after 1984 is going to be 1992. A great year where my fiance was born. So looking at these choices, we kind of want to pick one that is 8 years after 1984. So this one looks pretty good. What other ones could we look at? Well, this is 32.91 years after, so that's if you flip the y value with the x value. And this one, it says the 1984, the predicted population was 32.91. That's not true. That would be actually the starting value is 24.8. So we can cross that one off too. And in 1984, the predicted population was approximately 8 million. Again, not true. It should be 24.8. So C is the best answer here because 8 years later, or 1992, we would get 32.91. Question number 8. A right circular cylinder has a volume. So as soon as they tell me the volume of something, I like to draw a picture of a geometry shape as well as write down the formula. All right, we have the volume is 377 cubic centimeters. So write that down. The area of the base is 13 square centimeters. Well, area of the base is a circle. So area is pi r squared, which they told us is 13. Now from here, you could solve for the radius by dividing by pi and then square rooting it. However, the question is asking for the height. And so while you can do a lot of extra work, I can do a substitution and replace the pi r squared here with the 13. When I do that, I get 13 times h is equal to 377. And that should give us h is equal to 29. Technically, it would be 29 centimeters. And that makes sense too, because this is square centimeters. So you take centimeters cubed, divide by centimeters squared, you get centimeters. On to the next one. Question number 9. The list gives the massograms of 5 alpine marmots. And we have 4,010, 4,010, 3,030, 4,050, 3,050. What is the mean mass in grams of these 5 alpine marmots? So whenever you are looking for the mean of something, it's usually find the average or the arithmetic mean. So we're going to jump to Desmos. And I'm just going to type in the word mean and then type in the 5 numbers. You could also do this on your calculator. You could also just add the 5 numbers and divide by 5. There's a bunch of options you could do there. But I got 3,630 as our answer by adding them all up and dividing by 5. And that is the correct answer. Now, question number 10. X equals 3, y equals 15 minus x squared. A solution to the given system equation. What is the value of x times y? So we could graph this on Desmos and find the point of intersection and then plot it in, which is pretty good. However, this is a very simple linear system of nonlinear equations. So I'm going to plug in x is 3 right into the equation. Y is equal to 15 minus 3 squared, which is going to be y equals 12 squared, or 144. And now we have to remind ourselves to multiply the x times the y, so 3 times 144. As you can probably guess, just estimating alone, that's 300 and more, so it can't be B, C, or D, and the answer is A, 432. Question number 11. What is the value of cosine of A in the triangle shown above? Well, it says the figure's not drawn to scale, so we can't like measure it out and say, oh, that looks like 41, so this must be 41. But we know it's a right triangle, and it's asking about cosine. So cosine, if you recall your SOHCAHTOA, cosine is the adjacent side over the hypotenuse. So hypotenuse must always be opposite the right angle, so we know that the 42 must be the hypotenuse. And because we're doing angle A, 41 is the adjacent side. And then BC would be the opposite side. So in this case, they gave us exactly what we need to find the cosine of A. The cosine of A would be 41 over 42, and B is the answer. Question number 12. A circle has radius of 43 meters. What is the area? Well, they asked for area of a geometric shape. So again, I like drawing a picture. Here's the radius, which is 43. And then the area formula is pi r squared. So looking at this case, we have the radius already. So we can just plug it in. Pi times 43 squared. And you can, of course, get your calculator out. But if you estimate it, 40 times 40 is about 1,600, or definitely more than these other answers. So the answer is D, 1849. Question 13. An object has a mass of 168 grams and a volume 24 cubic centimeters. What is the density? Well, density is going to be mass over volume. And if you forgot that, it's okay, but sometimes it can help you to look at the units. It says what is the density in grams per cubic centimeter. So again, G over centimeters cubed. So in this case, we put the 168 grams on top and we put the 24 down below. And as you can probably imagine, 168 divided by 24 is about 5, 6, 7. You can also use your calculator and get the answer to be 7. Question 14. A company has a newsletter. In January 2018, there were 1,300 customers subscribed to this newsletter. For the next 24 months after 2018, the number of customers subscribed to the newsletter each month was 7% greater than the total number subscribed the month before. Okay, so this looks like an exponential growth model, and we're going by months. Which equation shows the number of total customers subscribed to the company's newsletter M months after January 2018, where M is less than 24? Okay, so looking at our exponential model, we're going to have the starting number of 1,300. And because it's exponential growth, it's going to be 1 plus 7% over 100, raised to the number of times we do this. Because this happens every month, we're going to raise it to M months. Once we have that down, it makes it pretty easy. So they all have the 1,300 in front. So that's consistent. Now, A looks very tempting because it's 7%, but that would be an exponential decrease model. It would be going down rapidly. If we look at B, though, that is exactly what we want. It's 1 plus 7 over 100. And then C would be a 70% increase. And then this would be a 600% increase. So if you got tricked by these other two, review the less than on percent increases. Question number 15. A scatter plot shows relationship between two variables, x and y. A line of best fit is also shown. For how many of the 11 data points does the line of best fit predict a greater y value than the actual value? So this predict word means the line of best fit. So we're looking for when is the line of best fit more than the actual y value. So let's look at that. So for the first point, that's not the case because the actual value is more than the line. So we can cross off that one. We can cross off this one. Looking at the next one, that's good. That's good. That's good. They're all below. cross off, circle. So we have 5 so far, cross off, circle. So this one was kind of understanding the wording and the verbiage is used on the SAT. So predicted is by the line of best fit, and actual are the actual data points. So we have a total of 1, 2, 3, 4, 5, 6, and 6 is the answer. Question number 16. In the figure above, RT is equal to TU. So this is a little tricky because that diagram is cut in 2 places. So, but I'm going to mark like that. And I know that because it's an isosceles triangle, these 2 angles are equal. The measure of angle VST is 29. And this is also interesting because it's part of there's a top triangle, there's a big triangle. So there's going to be probably something about that we need to worry about. So 29 degrees. And the measure of angle RVS is going to be 41 degrees. Okay. What is the value of x? So x is the top one. So my plan of attack is probably to find either the angle next to RTU or find the base angles of the isosceles triangle and go from there. So what can we do? Well, one thing we might do is might want to put some terms in here. So like I might put this as y and this is y. And then looking at this, we also have kind of like a 180 minus x there. And we're looking to find out some common area. Now, something also to keep in mind is looking at the big triangles as well. So we have the 29 here, which is also applying to that triangle there. So what can we do? Well, things to think about is if I look at just the small triangle, we have 41 plus y plus this kind of top angle, which we'll call z, and that's equal to 180. But we don't know what z is, and we don't know what y is. So I'm going to put that on hold for now. Now, something interesting is I know that this is 41, so I could do 180 minus that to get to the angle over here. So that would be 180 minus 41, which is 139. And then if I highlight this big triangle, I now have 2 of the 3 angles. So then we can do y plus 29 plus 139 is equal to 180. And that looks like where I want to go from here, because now with y, I can then go solve for x. So adding 29 to 39, we get y plus 168 is equal to 180. We get y then is equal to 12 degrees. Again, very small angle. It does not look like the diagram of all, but again, figure not drawn to scale. From here, we can then do x plus 2y is equal to 180 because of the isosceles triangle rule. And so x plus 24 degrees is 180. And then x is equal to 156, which is the correct answer. All right, a little bit trickier on that diagram, but once again, remembering your rules for the geometry. Geometric triangles and similar triangles and isosceles triangles. So keep them in your mind when you're doing these type of problems. All right, question number 17. So for question number 17, it asks how many solutions does a given system equation have? Well, a system of linear equations can never have exactly 2. So it must be either exactly 1, infinitely many, or 0. So 0 would be when they're parallel lines. Infinitely many is when they're exactly the same line. And then exactly 1 is what you normally see in every math class. So what can we do with this question? Well, one thing, I look at the numbers and they look very familiar. So I'm going to multiply the bottom one by 2. And on top, we have negative 12x plus 14y is equal to 36. And on the bottom, we have negative 12x plus 14y is equal to negative 36. So they're almost exactly the same line, but not quite. So then is it going to be exactly 1 solution or 0? Well, because they are almost the same line, but not equal, it's going to be most likely parallel. And if you do the slope of the 2 lines, you're going to get slope is equal to negative 12 over 14, which is 12 over 14. And the bottom one would be the exact same. So the slopes are equal, which means that the lines are parallel. You, of course, could have graphed this on Desmos, and you would see that the lines are parallel. So that would also have worked too. Question 18. The expression 0.35x represents the result of decreasing a positive quantity x by what percent? So this is a percent decrease. So again, if you got stuck on this question, review the lesson on percent decreases. So what we do for percent decrease is we always write 1 minus the percent decrease over 100 times the starting amount, which is x. And then we put it equal to the final amount, which is, they told us, is 0.35x. So we divide both sides by x, we get 1 minus the percent decrease is equal to 0.35. That looks a little funky. I'll make it a little bit smaller. There we go. All right, we then subtract 1, which is going to give us 0.65 times those sides by 100. And we get 65%, which is the answer D. So if you're going through quickly, you might pick B because 35%, that looks like 35%, but when you're doing percent decrease, you subtract it from the 1. So keep that in mind when doing these types of problems. Question 19. Object R and S each travel at a constant speed. The speed of object R is half the speed of object S. So VR is equal to 1/2 VS. And again, I use V for velocity as a teacher. So you can also use S if you prefer. Object R travels a distance of 4x inches in y seconds. Okay, so VR is going to be 4x inches in y seconds. So its speed is basically 4x over y in inches per second. Well, since we know the speed of R, we then know that S is going to be double that. So then Vs is going to be 8x in y seconds. Which expression represents the time in seconds it takes object S to travel a distance of 24 inches? So we know that velocity is distance over time, and then that means that time is equal to distance over velocity. So I'm going to take the distance of 24x and divide it by the 8x over y. Whenever we divide by a fraction, we multiply by the reciprocal. And now something cool happens. The x goes away, and then 24 divided by 8 is equal to 3. And we're left with 3y seconds. The answer is B. Question number 20. The graph shows a linear relationship between x and y. So again, we see a y-intercept here at 0, 6. We see an x-intercept here at 2, 0. We could find the slope if we needed to. Which equation represents the relationship where r is a positive constant? Okay, so that's kind of a weird way saying r because you don't have any idea what r represents in the diagram. So what we probably want to do is pick which points go into the graph and eliminate ones that don't. So starting with A, if I plug in 0 for x and 6 for y, I would get r times 0 plus 18 times 6, which does not equal 36. So we can cross off A. If we try B, we get same point, r times 0 minus 18 times 6, that does not equal negative 36. So we can cross off B. Now, because you just plugged in 0, 6, you may want to try that again for C. But when we try that, it's not going to help you because you're going to get 6 times r is equal to 36, which may be a true value. We'd have to solve for r. So instead of plugging in the y-intercept, we're going to want to switch gears and go to the x-intercept. So we're going to do 18 times 2 plus r times 0 is equal to 36, which is true. So that gets a yes for me. And lastly, plugging in again the x-intercept, we get 18 times 2 minus r times 0 is equal to negative 36, and that does not work. So that was kind of like the method for solving this problem. We didn't know anything about r, so we used values on the line that made r become irrelevant by timesing it by 0. So things to think about whenever looking at lines is the x-intercept, the y-intercept, and the slope. All right. Question 21. 2 more to go. A sample of a certain alloy has a total mass of 50 grams and is 50% silicon by mass. Okay, well, 50% of 50 is going to be 25 grams silicon, which again is Si on the periodic table of elements. The sample was created by combining two pieces of different alloys. Okay, so this sounds like a mixture problem from Algebra 1 classes or Integrated Math 1. The first piece was 30% silicon by mass, and the second was 80%. So whenever a mixture problem, you can have technically any number of mixture problems, but they usually have to have just have two items. So we could write it as a decimal or as a whole number. I'll do it as a whole number, but most people like to do decimals because it makes the number smaller. So you can kind of imagine that it's 30 times F for the first piece, and then plus 80 times S for the second piece, and that's going to equal 50 times F plus S. That's a pretty common scenario, but you can't have two variables with only one equation. So the other equation that a lot of people don't recognize is that the masses must add up to the total mass. So instead of using two variables here, we can reduce it down to one variable by doing a substitution. And because the question is asking for the mass of the second piece, I'm going to focus on getting rid of the first mass. So 30 times 50 minus S plus 80 times S is equal to 50 times 50. Once again, we could have made these all decimals, and it could make the number smaller. Actually, let's just do that. Might as well. 50% becomes 0.5, 80% becomes 0.8, and 30% becomes 0.3. All right, so 30% of 50 is 15 minus 0.3 S. 80% times S is going to be 0.8 S, and 50 times 50, half of 50 is going to be 25, which we found earlier. All right, combine the S's and subtract the 15. So subtract 15, combine these two terms, and we get 0.8 minus 0.3, which is 0.5 S, is equal to 10. And then we multiply both sides by 2, or you can divide both sides by 0.5, and S is equal to 20. There we go. So this is a very common question on the SAT. It's called a mixture problem. So basically they do percent of something plus percent of something is equal to a new percent of the total. So keep that in mind, and this is how you can always solve these types of problems. Question 22. You've made it to the end. Congratulations for reaching the end of Module 1. Let's go through it. The product of two positive integers is 462. All right, and so I might just do x times y is equal to 462, where x is one positive integer and y is another positive integer. If the first integer is 5 greater than twice the second integer, so I don't know which one is the first, so we'll just do x is the first. So let's write that down. So the first integer is 5 more than twice the second integer. What is the smaller of the two integers? All right, cool. Now you can definitely do a substitution here. You can also graph it on Desmos. For this problem, I'm going to graph it on Desmos. So yx is equal to 462. And then we have the second equation, x is equal to 5 plus 2y. All right, and we are looking for solutions on this graph. So I might have to zoom out a bit, but there we do. We have 33, 14, and we have negative 28, negative 16 fifths, negative 16.5. Now, it might be confusing on which one is the right answer, but the question said positive integer, so we can cross off the bottom one because those are not positive, and the last one's not even an integer. That leaves us 33, 14. And it said, what is the smaller of the two integers? So we can pick 14. All right. That's all it is for the first module. I'll see you in the next one. Welcome to Math Module 2, Question 1. Let's begin. In the figure above, two lines intersect at a point. If W is equal to 136, what's the value of Z? So even though the figure is not drawn to scale, whenever two lines intersect, we form an X, and then we get something called vertical angles. And I like to call them opposite angles, but the vertical angles are always congruent if there are two lines intersecting. So because W is 136, Z is also 136. And that's the answer for question 1. Question 2. If 2x plus 3 equals 9, what is the value of 6x minus 9? So the first thing I was going to solve for 2x, and that's equal to 6. Now I could divide both sides by 2, get x equals 3 and plug it in, but I could also multiply both sides by 3, and that gives me 6x equals 18. And then we want to do 6x minus 1, so it's going to be 18 minus 1, or 17. But yeah, solve for x and plug it in, or solve for the expression. Either way will work for the SAT. Question 3. We have a scatter plot here. Which equation is the most appropriate linear model for this relationship? Okay, so we can kind of eyeball it and see that it's basically like looking something like that. And probably looking at the y-intercept, which was 0, 2 point something. So it's not going to be a negative 2.2, probably a positive 2.2. And then the next thing we want to look at is the slope. I notice the slope is positive and increasing, so I don't think it's a negative slope. And then the answer is probably D. If you actually had to have a harder time finding out what's the values, you may want to go to Desmos and use the table method to do the linear regression model yourself. But the answer is D, because it has the positive y-intercept and a positive slope. Question 4. The equation above shows the estimated amount of diesel, D in gallons, so we have units provided, that remains in a gas tank of a truck that after being driven X miles. So that just tells me that 16 is the total amount of gas in the truck, and then over time, as you drive further, the amount of diesel goes down. What is the estimated amount of diesel in gallons that remains in the gas tank when X is 300? Okay, so this is actually, since the D is the remaining, this is a pretty simple question because you just plug in 300 in for X. So 16 minus 300 over 30. You can take out a 0. 30 over 3 is 10. So D is equal to 16 minus 10, or there will be 6 gallons of diesel left over. So be careful with that, but definitely the question was a little bit easier because D was the amount of remaining versus the amount that was consumed. So that would have been a different setup that they could have done. Question number 5. G of x is equal to 11x plus 4. For the given linear equation, which table shows 3 values of x and their corresponding g values? So we're plugging in different x values and see what the y value is. Now, one thing I noticed is that all of the x values are the same. So this basically looks like a pretty easy question. So I do g of negative 1, which is going to be a negative 11 plus 4 is equal to negative 7. G of 0 is equal to 0 plus 4. And then that's 4. And then g of 1 is equal to 11 plus 4, which is 15. So the first one has the wrong values except for the last one. This one has the wrong values at all cases. This one looks great on all values, and this one is wrong. So C is the correct answer because it has the corresponding y values for the x values. Question number 6. The pressure exerted on a screwdriver at sea level is 14.7 pounds per square inch. Again, we have units. For each foot the screwdriver descends below sea level. So for each foot, sounds like it's probably going to be a ratio or a rate. The pressure exerted on the scuba diver increases by 0.44. So that could be either 0.44 psi per foot, or it could be for 1 foot, it goes up by 0.44 psi. Let's keep reading. What is the total pressure in psi exerted on the screwdriver at 100 feet below sea level? So we're looking for pressure, and we know the rate then would be 0.44 psi over feet. And you can kind of remember how to figure out which one goes on top because it's change in y or change x. So if your y variable is p or pressure, you want the pressure on top per 1 foot. And then we're going to multiply this by the amount of feet. And then there was an initial. So when the distance is 0, it was already had some pressure of 4.70. So now how do we figure out the answer? Well, because they went 105 feet down, we're going to find the pressure at 105 feet. So what does that equal? Well, it should be 60. And the reason why I was able to figure that out is if you do zero point 0.4 times 100, that's about 40-ish. And then if we add 14 to that, that's 54. So B is too small, C is too small, D is too small. So the only one that's close is A. But of course, you have a calculator, you have Desmos, so you can find the exact value at every single time. But if you can do this estimation technique, it can help you save time. Question number 7. The function f is defined by fx equals 4x to the negative 1. That's a pretty tricky notation because it's not 1 over 4x. It's going to be 4 over x, or 4 times 1 over x. So a little tricky, but f of 21. So for f of 21, we're going to plug in 21 for x, and we're going to get 4 over 21, which is the answer C. So definitely, if you pick B, you got a little tricked by the negative exponent. It wasn't the whole quantity raised to the negative 1, just the x variable. Question number 8. The area of a rectangle is 57 square inches. So I'm going to draw a rectangle because there's not one drawn. And we know area is width times length, which is currently 57. The length of the longest side of the rectangle is 19. Okay, I'm just going to say that this is 19 then. And I'll say that this is W. So then W times 19 is equal to 57. And then we can divide both sides by 19. And W is equal to 3 inches. What is the length of the short side? All right, so 3 is less than 19. So then 3 is the answer. Question number 9. How many yards are equivalent to 77 rods? Now, most people don't use rods nowadays, but this is just a unit conversion. And as long as we make the units cancel out, it will work out every single time. So start with what's given, 77 rods. And then we do our parentheses conversion factor. And I notice that this has rods and this has yards. So I'm going to put 1 rod on the bottom, and I'm going to write 5.5 yards on top. That way, the rods cancel, and we are left with yards. So what is 77 times 5.5? Well, let's go to Desmos and type it in. 77 times 5.5, and that's 423.5. Because it didn't tell us to round to the nearest whole yard or anything like that, I would want to make sure to type in all the decimal places, and that is the maximum number of characters you can type on Blue Book app, because it's 1, 2, 3, 4, 5 characters. So that looks good. Question number 10. X squared minus 12x plus 27. How many distinct real solutions does the given equation have? Well, a quadratic can have a maximum of 2. It cannot have infinitely many. So when they ask this, it's usually asking about the discriminant test. So if you recall the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac, and then over 2a over 2a. The discriminant test is the inside of the radical. So in this case, a is the coefficient of x squared, which is 1. B is the coefficient of the linear term, which is negative 12. And C is the constant term, which is 27. All right, let's plug it in. Negative 12 squared minus 4 times 1 times 27. And that is equal to something. So 144 minus 108. Yep. So that is a positive number. So when the discriminant is positive, the quadratic will have 2 solutions. I don't know where, but it will have at least 2 solutions somewhere. Now, while you do not need to memorize this to do like this type of question, it's definitely very powerful for the questions where there's a bunch of letters involved. But just to confirm that we did get the right answer, we're going to go jump into Desmos and type the graph in. X squared minus 12x plus 27. And we can see that there are indeed two real solutions. So, all right, next one. Question 11. Question 11. For the linear function g, the graph y equals g of x in the xy plane has a slope of 2 and passes the point 1, 14. So immediately I'm going to use something called point slope form. X minus h plus k, where hk is the point and a is the slope. I guess we could change it to m. There we go. Same thing, but look more familiar. Y equals 2, x minus 1 plus 14. So I'm going to look for the answer first, but we don't see it initially. So that means we need to simplify this a little bit. 2x minus 2 plus 14, y equals 2x plus 12. And these all have the same slope, but then the one we're looking for is c with the y-intercept of 12. Question 12. So we have a portion of the graph above, and we're looking to make some estimation or interpretation of the graph. So the graph gives the estimated population y in thousands of town X years since 2003, where it's between 0 and 5. So this is 2003, and then 5 years later is 2008. Okay, I see a y-intercept of 6,000 people here. So let's keep going. Which applying best describes the increase in the estimated population from 0 to 1? So from 0 to 1, so 1 being 2004, it went up to 9,000. So one way of thinking about it is it for the 1 year increase, or from 2004 to 2003 to 2004, it went up by 3,000. We can also do a multiplication factor, but probably the best way is to look at the answer choices and to cross elimination. The estimated population at x equals 1 is half times the estimated population at 0. Well, 9,000 is not equal to half of 6,000. So it's not A. B, the estimated population at 1 is 1.5 times the estimated population at 0. That is true. 9,000 divided by 6,000 is 1.5. So that is probably the answer, but let's check the other two. The population is 2.5 times. No, that's too big. And 3.5 times. No, it's too big. So B was the right answer. Now, something to be aware of is instead of saying 1.5 times, they could have said that it is a 50% increase. So that's where you might get stuck thinking it's A because you're remembering all the harder percent increase problems. So keep an eye on the wording. So if it said what percent increase, then 50% increase would be another way of interpreting this graphic. Question 13. In March, the price of a collectible card was $15.50. In April, the price of the collectible card was 17.36. The price of the collectible card in April was P% of the collectible card in March. What was P? So this is not a percent increase or decrease. This is what percent we're looking at. So we're going to follow proof. Percent of original equals final. So I'm write P over 100 because it's a percent times the original amount in March is equal to the new price or final price in April. All right, from here, we divide both sides by 1550. And I would use my calculator, but just to show you the work, I'll pull up Desmos. So 17.36 divided by 15.50. And that is 1.12. All right, multiply both sides by 100, and P is equal to 112%. So now, if the question was asking what percent increase did it go up by, then it would be A. But because we're asking what percent of it, it is C as the answer. So keep your eye on that. And then if you got flipped, if you reverse the numbers, you might have gotten B or D as your answer choice. So it's not always a small over big. It is final divided by original is how we can find the percent. Question 14. X is equal to 8a times b plus 9. The given equation relates the positive numbers a, b, and x. which equation correctly expresses A in terms of B and X? So we're going to be following SAD meet, which is PEMDAS spelled backwards. And we're trying to get A by itself. So currently A is being multiplied by the 8. It's also being multiplied by the B plus 9. So in order to undo the multiplication, we're going to do division. So then X divided by the 8 and divided by the B plus 9 will equal A by itself. So let's look for that answer choice. This kind of looks right, but it looks like they divided and then subtracted the B plus 9 over. So it's not quite right. This looks perfect. Let's check the next one. So that one is they flip the order. So that would be kind of like if you divide by X instead of dividing by 8 and B plus 9. And then this is instead of dividing, you multiplied. So the correct answer that we're looking for is B. Question 15. Line J is shown in the xy plane. And again, I see a y-intercept pretty easily, 0, 5. The x-intercept is not as easy to identify, but there's a point above it that I could use if I need to find the slope. Line K not shown is parallel to it. What is the slope of line K? Well, if two lines are parallel, they have to have the same slope. So that means I must find the slope of the first line. And I also see that they labeled a point right here. So I'm going to use that one. So we have 1, 9. And pretty quickly, I can see that the slope is going to be a change of the y variable. So 9 minus 5, which is 4, over 1 minus 0. So 4 over 1 is the slope. And because they're parallel, they must have the same slope. So slope of j is 4, then the slope of k must also be 4. Question 16. A line segment has a length of 115 centimeters, is divided into 3 parts. Okay, so we have a line segment, and we know the total is 115. One part is 47, so I'm going to go from here to here is approximately 47. The other 2 parts have lengths that are equal to each other. So that's going to be x and x. And we know the total must equal 115. So already you might be thinking 47 plus 2x is equal to 115. Well, let's keep reading. What is the length of one of the 2 other parts? So we don't need to find the whole length of both parts, just find basically what x is. So 47 minus 115, and then dividing it by 2. All right, so let's set it up. So first off, we subtract 47 from both sides, and then we will divide by 2. So going on to Desmos to show you the math. I'm going to press the fraction button. Perfect. 115 minus 47. And then if I press divide by 2 like that, you notice it only divides the last one. So it's important whenever you're dividing, you make sure to put parentheses around the numerator. That way it divides the whole thing. So we get 34 is our answer. And that is the correct answer. Question 17. P of x is P of x plus 57 is equal to x squared. So that's weird because normally we don't put things on the function side. So the first thing you should do is move it on over. All right, now it looks like a parabola. Perfect. The given equation relates the value of x and its corresponding values p of x to the function. What is the minimum value of p? Well, this could be vertex form where y equals a times x minus h squared plus k, where in this case a is 1, and then it's x minus 0 squared minus 57. So the vertex is at 0, negative 57. I could also graph this on Desmos. But I think what they're hoping for you to do is instead of writing out the formula normally, I think they're hoping that you would get mixed up with having the plus 57 on the left. So just x squared minus 57. So then we might have to scroll down a bit to see the minimum value. But there it is, negative 57. So, and when it asks for the value of something, that is not the location, that is actually for the y value. So the answer is indeed B. But if they ask where was the maximum or minimum occurring, then it would be 0, the x value. So kind of tricky, but not too bad. Question 18. The table shows 2 values of x and the corresponding y values. In the xy plane, the graph of the linear equation representing this relationship passes the point 1/7 comma a. What is the value of a? Now, we can find the slope the long way, but I want to show you how to do the slope using the table method on Desmos. So it's pretty convenient, especially when the numbers are bigger and harder to work with. So all you do is you type the word table, and then you just type in the points that you see. And I'm pressing tab to quickly navigate through the different columns. So there we go. Now, the question said it's a linear model, so I'm going to focus on doing a linear model. Now, most people write y equals mx plus b. Well, that's not going to work because we want to match the table values. So instead of writing y equals, you do y1. And instead of doing x equals, you do x1. And all you have to do is just press the 1 right after the variable. Now, it's almost working, but still kind of upset. So in order to tell Desmos to make this a linear regression, we use the tilde symbol, which is next to the number 1 on the keyboard. And then that's it. We now have this beautiful function where the slope is 4 and the b is 24. Okay, but how do I figure out what a is at 1/7? Well, you could write these numbers down on your paper and plug it in manually. However, you could also write f of x is equal to mx plus b. And because Desmos is smart, it takes the m and b that it found earlier and puts it in there. So now we just have to type in f of 1/7. And there we go. The a value is 24.57. Now you're like, nah, what fraction is that? Well, you press the fraction button, boom, 172/7, D is your answer. So it's kind of pretty cool how powerful Desmos is, and that's why I encourage you to play around with Desmos, not just when doing the test, but when also doing homework questions. Use it and make it be your best friend. Talk to it, sing it love songs. It will help you a lot on the SAT. All right, enough silliness. Let's go on to question 19. Question 19. Y equals 576 raised to the power of 2x plus 2. So that's already looking weird compared to normal. Normally, we write things like y equals a times b to the x. The graph of the given equation xy plane has a y-intercept of r, s. Well, r must be 0 because any y-intercept of any graph is when x is 0. Which of the following equivalent equations displays the value of s as a constant, coefficient, or a base? So all we have to do is plug in 0 for x and find what the y value is. Let's do it. So 576 raised to the 0 plus 2, which is going to be 576 squared. Well, I don't know about you, but I'm guessing it's 331,000. But let's check on Desmos. We don't want to make a mistake by being too much pride in our math skills. Exactly 331,776. So then, based on the wording on the question, we're looking for which of the following equations has that number as a constant, coefficient, or base. So this has it as a coefficient. This does not have it. This does not have it. This does not have it. So boom, boom, boom. Now, one thing that's kind of confusing about this is it's not saying which of the following is equivalent to the above equation. It's saying that these all match. So these are equivalent. They all match each other, but we're looking for which one had this number. So that's where sometimes you can get confused or tricked by the wording in the question. But we're all done with that one. On to question 20. Question 20. If k minus x is a factor, well, that one thing that's kind of confusing because normally we write factors as x minus the number. So it's a little reverse of what we normally do. Of the quadratic negative x squared plus 1/29 n k squared, where n and k are constants and k is greater than 0, what is the value of n? Okay, so one thing I might want to think about is synthetic division, long division, or just trying to factor it by hand. So what do I mean by factoring it by hand? So first off, I put k minus x here, and I'm going to times it by something, and it has to match up with negative x squared plus 1/29 n k squared. So kind of like matching it up is like, I know I must get a negative x squared. There must be an x somewhere. And I know I have to get a k squared and an n, so there must be an nk. And then there needs to be a 1/29 somewhere, so maybe over 29. That's kind of what I'm thinking so far. Well, let's see if that foils out. So negative x, all right, k minus x and then x n k over 29. So we get xk negative x squared, and then we get nk squared over 29. And then lastly, we get negative x nk over 29. Okay, so we do have the final things, which is what we were looking for, but we have these extra terms in here. And so that's where it can be kind of confusing, where what is the answer supposed to be? Well, that's actually the next step, is because n and k are constants, not variables, that means that kx minus uh, kn over 29 x must equal 0. So from here, we can figure out that if by setting them equal to each other, kx is equal to knx over 29. The k's cancel, the x's cancel, and so we get 1 is equal to n over 29. So therefore, n must be 29. Okay, that's one way of doing it, but it's a little tricky. What about synthetic division? So for synthetic division, we take the polynomial and we take the coefficients of it. So currently, since it's negative x squared, 0x, and then plus 129 nk squared, we're going to write negative 1, 0, and then n over 29 k squared. Then we are dividing not by x, but by k. So the way you can always find the 0 of synthetic division is figuring out what makes it equal to 0. So put a k here. And it is a factor, so the remainder must be 0. So we bring the first number down, and then that's negative 1 times k, which is negative k. Add these together, which is negative k. Multiply them together, you get negative k squared. And normally you would add these two together. So that's going to be n over 29 k squared plus negative k squared. But because it's a factor, it must equal 0. So as we can kind of see here, we can set them equal to each other. And the k squareds cancel out, leaving you with 1. And so again, n must be 29. So it's a pretty tricky question, but definitely there's a lot of algebra terms in there. So keep an eye on them there. All right, let's go on to the next one. Question 21. We have two triangles and then figures not drawn to scale. In the figure, LQ intersects MP at point R, which we can see. LM is parallel to PQ. Okay, so that means we have alternate interior angles. So these are similar triangles. So triangle LMR is similar to triangle QPR. All right. The lengths MR, LR, and RP are 6, 7, 11. So those are not labeled, so I'm going to write them on there. So we have 6 here, and then LR is 7, and RP is 11. What is the length of LQ? So we kind of need to figure out this side here. Well, one thing we did is we made up the fact that these triangles are similar, which means that the sides are proportional. So MR must match up with PR. So that means 6 over 11. And then LR must match up with QR, which is conveniently what we're solving for. All right, we do a little cross multiplication. And we get 6 equal to 11. And there's a 7 here, and then the QR here. And then, as you can imagine, we can then get the answer by dividing both sides by 6. So we want 77 over 6, which is B, and that is the correct answer. All right. Congratulations on making it to the final question in Math Module 2 for this PSAT test. Let's go through it. So First thing I noticed is that that's the linear model, and then this is a quadratic model. So they normally write these as like y equals something and y equals something, but this time they wrote them already substituted equal. Now you could focus on just that alone. There's a lot of tricks you could do here, but one thing you may want to do is graph them on Desmos and find the intersection points. So I'm going to start with that technique. And I like to not just do y equals, but f of x and g of x. So 5x plus 7 is one line, and then g of x is equal to 15 times x minus 17 and x plus 7. All right, so, and another thing we have to keep in mind on is it said find the sum of the solutions. So we have one solution here. I'm going to copy that over. And then we have the other solution here. Copy that over. Perfect. Now, another thing you could do instead of those two, especially since it's sometimes hard to find the actual y values, is that you can do just f of x minus g of x is equal to 0, because when it's equal to 0, that means the y values are the same. So scrolling back down, now you can just find those x values pretty quickly too. Well, how do we add these two numbers together? Well, I'm going to copy the first number and add it to the second number. And I get 10.33333. So as you might imagine, type in 10.33. And that would definitely be the correct answer. What other way could we do this? Well, there's a cool little trick using some special rules of quadratics. And you can get this answer very quickly. So first off, we're going to multiply things out and set it equal to 0. So 15x squared minus 10x minus 139. Doing 7 times 17, 119, sorry. There we go. And then that's equal to 5x plus 7, but we're going to set it equal to 0. So 15x squared minus 150x minus the 5x from the other side minus 119 minus 7 is equal to 0. Perfect. Now the sum of any quadratic, whether they're real or imaginary solutions, is going to be negative b over a. That's it. So in this case, we could just do negative 155 times negative over 15. Let's clean that up. 155 over 15, divide those numbers by 5, and we get exactly 10.33. Perfect. All right. I hope that was helpful for you. All right. Thank you all, and I hope you had a great time. Bye-bye.